So ANN means artificial neural networks. Artificial neural networks. So artificial neural networks where artificially they are created the neurons connections connected. So for example, if you are having three input neurons or three input with respect to three input variables x1, x2, x3 and y. If you are having three input variables, we are going to consider three input neurons and we are going to add a hidden layer as per the requirements. If you want to add a hidden layer means we'll add. If you don't want to add the hidden layer means we are not going to add. But the initial three input neurons will be selected based upon the given problem. Number of input variables is equal to number of input neurons. And if it is a regression problem means we have to select only one neuron in the output layer. If it is a for example, binary classification also we have to select only one. If it is a multi-class means we have to select as per the number of categories, right? Now, if you connect directly the input layer to the output layer, then it is called as perceptron model. Otherwise, if you are having any hidden layer in between and using the hidden layer, if you have connected them, then it is called as neural network. Whenever you are designing a neural network, now this is design. This is called as design. When you are designing the neural network, you have to fix the number of while designing a neural network. While designing a neural network, we have to select first how many input neurons. Input neurons in input layer. Input neurons in input layer is the first one. The second one, we have to select number of hidden layers. Number of how many hidden layers you want. We have to decide the number of hidden layers. Third, number of hidden neurons. That is number of neurons in the hidden layer. We have to select the number of neurons in the hidden layer. And fourth, we have to select number of neurons. We have to select number of neurons in output layer. 5. What type of weights initialization you want? Initialization, weight initialization. What initialization you want to select? 6. After weight initialization, activation functions. What type of activation functions you have to select in all the layers? In each hidden layer, what are the activation functions? 7. You should be good at what is the optimizer, whether it is a gradient descent or stochastic gradient descent. Optimizer. What is the optimizer you want? 8. What is the loss function you want to select? So these 8 things you have to keep in the mind. Then only you can design a neural network. For a regression problem, the loss function is equal to mean square error. We want the mean square error to be low. For regression problem, the mean square error we are going to select. If it is a classification problem, we require the accuracy. Accuracy should be very high. Okay. So here in the regression problem, we are going to select mean square error as the low. In the classification algorithms, we have to select the accuracy as the high. Okay. Now, optimizer, we are having the optimizers like gradient descent, stochastic gradient descent. We have to deselect which one we want to apply, right? So based on all these things, once we select, once we write the answers of all of them, then we can design the neural network, right? Initially, first neural network, whatever the first neural network you want to select, just take the values fixed. Here input neurons will be fixed. This is fixed. No changes in this. You can't change. Number of neurons in the output layer. This is also fixed. You can't change. Weight initialization. This is also almost fixed. Unless you see any kind of overfitting problem, then only we are going to change. By default, we'll go with the weight initialization uniform. 99% will go with the uniform. This is also fixed. Activation functions. It is also fixed. For output layer, what is the thing? And for hidden layers, this is also fixed. No changes. Or optimizer, this is also fixed. We can't change that one. Okay. Either we are fixed means, oh sorry, not fixed. It is having either gradient descent or stochastic gradient descent. Loss functions are fixed. This is not change. It will not change. Now only question is number of hidden layers and hidden layers we don't know. So since we don't know those two, first we'll give you any some value. Initially some value. And remaining things, whatever the others like, sir, instead of weight initialization uniform, we are having he int uniform, he int normal. We are having all these things. Now, why you are selecting uniform only? By default, we'll go with the simple one. We don't want to make by default itself the complicated one. In the regression algorithms also, first we'll select the linear regression as the assumption model. Linear regression is an assumption. Though we assume that relation is linear. Why will assume? Why will assume? Relation is though it is non-linear also, by seeing the scatter plot also, we'll understand it is non-linear, but still we'll assume the linear. Why? Because we required our output, whatever the equation is there, that should be very simple. It should not be more complicated. As the degree increases, what happens in the polynomial regression? The more the degree, the number of parameters increases. Beta 1, beta 2, beta 3, beta 4, beta 5, beta 6, beta 7, beta 8, beta 9. Like this, the number of parameters increases. As the degree increases, the more number of coefficient values increases. And it leads to the overfitting. So what we assume is the example, whatever the initially for the given data, we assume it will fit in a simple model. If it is not fitting in a simple model and you are not getting the better answers, only we'll do the modifications. If the simple model itself is giving the better answers, why you have to think too much? Right? So by default, we are going to take as a simple model. And for that simple model, we are going to add the, based on seeing the answers only, we'll decide next one. Without seeing the answers, we can't decide. For example, very simple example, radio. You are having a radio where I have told you the knob is there and we have to rotate the knob and we have to hear the voice. In Hyderabad or in Andhra or in Telangana, you know the radio stations. 98.3 FM or 93.5 FM or whatever the radio stations are available, you know that one. Now the same radio, you go and take to the Assam. In the Assam, what is the radio frequencies are available? Sir, I will check in the internet and I will identify, sir. Without checking in the internet, now if you want to identify the radio frequencies in Assam, means from where you will start? The radio frequency starts from 0 to up to maximum of 150 frequencies are there. 91.3 is there, 92.8 is there, 99.5 is there. So many numbers are there from 0 to 100. Sorry, 150. In the radio knob, number of values are there. Where you are going to fix? Assume that you have went to Assam. You are in Hyderabad, means you know the radio stations. Now you have went to Assam or some other places, new place. There you don't know what is the frequency. Whether radio is available also, no, yes or no also don't know. You have to check. Then what you are going to do? Pure trial and error only, right? Complete trial and error. We'll start slowly and we'll rotate with respect to one by one, trial and error only. Complete trial and error we are going to make there. If you don't know anything. So here also the same. Instead of going with a blind of trial and error, we are having with respect to some basic things. And from there we are going to start. Why we are going to do this trial and error? Because for the data set to data set, the data values are different. The application is different. Values are different. Everything are different. So for different data sets, we want to get better answer means we have to do the modifications. If you create one model and this model will do always better only means never you can create a model like that. In your entire life, you can't create like that. Sir, I have created one model, sir. You apply whatever the data set in the, it will give the best answer. Without doing any hyperparameter tuning or nothing tuning you do, just it will blindly, it will give the best answers directly for this one with no doubt. None of them is there like that. Any person is having the certain advantages are there. If you consider Apple phone is having certain advantages. At the same time, Apple phone is having disadvantages. Samsung phone is having advantages, disadvantages. Similarly, a particular trainer is having some advantages and disadvantages. If you go with a person, some advantages, some with disadvantages. Every person will have some disadvantage. Everything will have some disadvantage. None of them is perfect. For example, in this weight initialization, uniform is always best means then no need to create others and no need to learn also. If that is the, for example, he int uniform, it is best always means, then no need to learn the normal uniform or no need to learn also. Directly we can learn the he int only. But he int is having certain disadvantages. Uniform is having certain disadvantages. What is the disadvantages means? The uniform will take more number of iterations. Will give multiple answer will be, you will get a good accuracy, but it will take more time. You have to give more epochs. Okay, because it is assuming everything are same and uniform distribution it is considering, right? So it is assuming everything of same. So it will take more time comparatively. That is a disadvantage. Okay, if it is a complex data, if it is a simple data, uniform is the best one. For small amounts of data, these are the best one. For large amount of data in the future, if you are working, in that case, it might be changed, right? So once we know all these 8 parameters, then only we can create our model. Here we have to create our own model. There is no fixed from Keras, import ann.fit on xtrain ytrain. Here it is not available. Machine learning algorithms, what we have done is import. Just we have done the import ML algorithm, step 1. Second one is save the model, some name, and model.fit on xtrain ytrain. Every time the same thing, right? KNN we have done the same, SVM we have done the same, logistic we have done the same, decision tree we have done the same. Regression and classifications, we have all the algorithms we have done the same. None of the algorithm we have changed. In the modeling, only these 3 lines of code we have used for all the classification and regression algorithms. But here, from Keras, import ANN, save the model name in some model. Model is equal to ANN. ANN.fit. This type of facility is not available in the deep learning. That facility is available in the machine learning. That facility is not available in the deep learning. In the deep learning, complete depends upon the design of the neural network. As the neural network design changes, everything changes. In future, they may bring. They are trying to do this, still more adjustments they are trying, and we may expect in maximum of 6 months to 1 year, maybe. Right? Now, first I'm going to import NumPy and Pandas. Okay. Next, I'm going to take the TensorFlow. I'm going to import TensorFlow as TF. TensorFlow. So now new library, we are going to work on the TensorFlow. By default, TensorFlow will not be installed in the Anaconda because TensorFlow will take maximum amount of RAM, or it will work on the GPUs. On rather than CPU, it will work on the GPU. Now, what is CPU and GPU? GPU means with respect to the graphics. If you are having the graphics card, it is going to be additional advantage. How you can see with your CPU or GPU means just click on the taskbar. Just click on your taskbar here. Once you click on the taskbar, there is an option called as performance. Just click on the performance. Here you can see your CPU and GPU. How much GPU it is working. When you are working on the TensorFlow, automatically maximum amount of GPU will be loaded. It is going to select your GPU, right? So here, my particular system is of i5 with 7th generation. I'm presently working on i5 with 7th generation. Now we are in the 12th generation. I'm working on the 7th generation. This is my training laptop. This is not my working laptop, right? So here I'm having with respect to this i5 with 7th generation. Here generation is not important. Here the number of cores. Here whatever the number of cores you are seeing here, it is there, right? This number of cores here, it is a 2 cores. That is a dual core processor. Mine is a basically dual core processor. Means 2 cores are there. Multi-threading will be done with 2 cores simultaneously, right? 2 things works at a time. But if you are having quad core or octa core, quad core means 4 cores will be there. Hexa core means 6 cores will be there. Octa core means 8 cores will be there. Then higher the number of cores, the processing speed will be the high. Very fast it will execute, right? So this is going to be depend on the number of cores in your processor. Along with that, memory, whatever the GB, that is RAM you are going to select, along with your GPU. So in my case, I'm having 4 GB graphic card. But out of 4 GB graphic card, just it is using only 0.2%. But inbuilt graphic card is sufficient for us. No need a separate graphics card for this system of working the GPUs or something like this. Okay. So since I'm working on the small data set, If large data set, based on the data set, it depends. The quantity, for example, if you are working on the 10 lakh records, and if you take a dual core system, it will die. So the more number of records are there, then you have to increase your configuration. For basic level and training purpose, if you work on the i3 also, it is not a problem. Okay. So just number of cores. So here TensorFlow, by default, TensorFlow will be not installed in the Anaconda. You have to install the TensorFlow. 100% you have to install. So how to install means pip install TensorFlow. Directly write your pip install TensorFlow in the Jupyter notebook. Copy the same thing and execute. So already earlier how you have installed the various libraries in the same way. Just install the TensorFlow. Earlier we are having with respect to like this. So earlier we are using the TensorFlow CNTK. CNTK is by Microsoft. Similar kind of TensorFlow CNTK is there. Similarly, Piano is there. This is one more library, Piano library. So earlier we used to work on the individual libraries. And if it is to be a lot of difficult while executing as the length of the code is very high. Earlier we used to work on them. But now Keras was built over them. Now whenever you are importing the Keras, automatically it is executing in the backend these things easily. So this is in the backend, this works, but in the front end, we are going to import only Keras. Keras makes the work very easy, right? And now here, import Keras. Once you click on the import Keras, automatically in the backend, TensorFlow works. Okay, TensorFlow was designed by the Google. TensorFlow is by Google. CNTK is by Microsoft. Piano is by Facebook. Okay. Now, here I'm going to import the TensorFlow and I'm going to import the Keras. And the TensorFlow version I'm going to work is 2.9.1. If you want to see any library version of that particular library, you have to write the library name. You have to select the library name dot underscore version underscore. Whatever the library. If it is pandas means pandas, numpy means numpy, sklearn means whatever the library. First step you have to import. For example, you have imported pandas. Import pandas and write pandas dot underscore version underscore. If you have imported pandas as PD, means then you have to use the shortcut PD here. Whatever the way you have imported, that one you have to use. Shortcut you have imported means you have to select that one. So here TensorFlow as TF I have imported. So TF dot version I'm asking. If I imported only up to TensorFlow means I have to ask TensorFlow dot underscore version. Any library you can see the version in this way, right? Now, so here my version is 2.9 version which I'm working, and if you are installing first time in the Anaconda, your version also will be the same. I have installed recently on this is the latest version only. Okay. Now, similarly, you have to install the Keras. How to install the Keras means pip install -- upgrade Keras. You have to install in this way. You have to write in the Jupyter notebook this line. This line you have to copy. Okay. So in this way, you have to install the Keras and TensorFlow. These are the two new libraries which we are going to work for the modeling. In the data pre-processing, no changes. In the data pre-processing, nothing changed. You are going to take the data, EDA is common. After that, treating the outliers, filling the missing values. If you want to do the scaling or if you want to do anything, that is common. Data pre-processing, none of the thing is changed. Nothing is changed in the data pre-processing. Only change will start from the modeling. From the modeling, only changes will start. Till that, there is no change. Right? Now, so first I'm going to load the data, which is called as energy data, where I'm going to predict the output called as energy in terms of kilowatt. Now here I'm having the temperatures, pressure, humidity, and vacuum. These are the 4 input values, and based on which I want to predict the energy, how much electricity is going to be consumed based on this, right? Now info, if I see the info, total 9,568 records are there. 9,568 records are there with total columns of 5 columns. The shape is 9,568, 5 5, out of which 4 input variables and 1 output variable. And the problem is a regression problem, where you want to predict the energy. Now, here the data pre-processing remains same. So what is the data pre-processing we have done in the earlier? That is, first we are going to do the EDA, common, no difference. Next, we have to treat the missing values, no difference. Encoding, no difference. If it is a nominal data, you have to apply the one-hot encoding or dummy encoding. If it is ordinal data, you have to apply ordinal encoding. There is no difference in the encoding. There is no difference in the missing values, nothing. You are going to clean the data. Now here, except the output variable, I'm going to consider remaining all in the input variables. That is X. If I open the X, all the 4 input columns. And similarly Y, which is the output column, as everyone knows, right? Now, here I'm going to split the data. Train test split I'm going to apply with 80% I'm going to use in the training purpose. Minimum of 70, maximum is 80. You should not cross more than 80 for your training. Minimum is 70. You should not give less than 70. If you give less than 70, it will lead to the underfitting. If you give more than 80, it will lead to the overfitting. Okay. And after training, we are going to do the, with respect to called as scaling. So why I'm going to do the scaling? Because here the higher the values are there. The values are very high. Whereas pressure is having very high values when compared to your temperature, humidity, or in terms of less than 100 means this is in terms of thousands. So I want to do the scaling. So I have done the scaling for this. So the scaling I have applied is standard scaler. Okay. I have brought all the values on the same scale. Why? What is the use of scaling? Scaling means you are bringing down to the on the same scale. Every variable you are going to bring on the same scale. Right? Now, here I'm going to build a neural network where number of input neurons are 4 and I'm going to have the 2 hidden layers and 1 output layer. In this first hidden layer, I want 6 neurons. In the second hidden layer, I want the 6 neurons. This is the one which I want to build. For this, how we are going to build? This one, how I am going to build means first import from keras.model, import sequential. First step is import sequential. You have to import. Second, from keras.layers, you have to import the dense. One is sequential, you have to import. Second one you have to import is dense. Now, what is meant by sequential? Now here, just observe this one. In the def means you are going to create. You know what is meant by user defined function. Forget about inside matter. Let us get into the inside. Now what I'm going to write, model is equal to sequential. Whatever I have imported here, I have imported the sequential. So I'm writing the model is equal to sequential. What is meant by sequential means whatever the order I'm going to add the things, that is a neural network. For example, if I add the first one as 6 neurons, input layer consists of 6 neurons. Because first you have added 6, right? First if I added 4. First I added 4 means input layer is 4. Whatever you are adding, in that order you have to select. Is that clear? Sequential means the way you add the neurons, layer by layer, in the order. Automatically the last one, after the last one, that is end means what is the last one is output layer automatically. In the whatever the order I'm adding, you have to take in that order. So I'm going to write model dot sequential. Sequential means first. First, you have to take model dot add. Add means you have to add. What you want to add? Input dimensions is equal to 4. Means 4 neurons it is going to select. Yes. Units is equal to 6. First 4 neurons along with the units is equal to 6 means hidden layer. At a time, you have to add the first input layer and the hidden layer you have to add at a time. Both you have to add at a time. And dense. What is meant by dense means connection. This is called as dense. It is going to give like this. Whatever the 6 neurons are there, it is going to connect like this. Right? So first, again, let us see clearly. Sequential. In the sequential model, I have stored in some variable name called as model. In the model, first I am going to add the 4 neurons. Input dimensions is equal to 4. Input dimensions means first one. The meaning is first one. Units is equal to 6. Automatically, the next one will be units. And dense means give the connections. This is called as dense. Whatever the connections I have made here, 4 into 6, total 24 connections are there, right? These 24 connections are called as dense. Now for this hidden layer, whatever the hidden layer I have taken, this hidden layer, I'm going to add the ReLU. And kernel initializer is equal to uniform. Means here the 24 weights will be selected on the uniform distribution between minus 1 by square root of 4 to plus 1 by square root of 4. From this starting value to this starting value, that is minus 1 by square root of 4 is 2 to plus 1 by square root of 4, that is minus 0.52 plus 0.5. It is going to select uniform distribution 24 weights. 24 weights will be selected between 0.5 to minus 0.5 to plus 0.5. It is going to select randomly. Means if you draw the histogram from minus 0.5 to 0, 12 weights will be selected. From 0 to plus 0.5, 12 weights will be selected. Randomly select 12 values from 0 to 0.5. Randomly. It is going to select randomly 12 weights between 0 to 0.5, 12 weights between minus 0.5 to 0, which is forming the uniform distribution. Total 24 weights will be selected, which forms the uniform distribution. Is that clear? Now, this is the one. Now here, if you observe this one, in this concept, what I have created is, I have added the dense. Basically, first step I have done is units. First is units. Units means 6 units. Input dimensions only for the first layer. For the first one, you have to add the input dimension. Input dimension, whenever the word of input dimensions is there, automatically it will come in the first position. Input dimensions should come in the first position. Okay. So first 6 for that input dimensions of 4 and connections of 24. Now, once 24 connections are connected, now what it is going to do? Next, for this one, now what I have completed? Only this part I have completed, this part I have completed. Inside this part I have given the ReLU and connections, and weights I have taken 24 weights with respect to uniform. From here to here only I have completed. Now next, for this model, I am going to add the next 6 neurons. Already this part is completed, right? For this one, I am going to connect the next 6 neurons. Next 6 neurons, I am going to take units is equal to 6 and activation is equal to ReLU, kernel initializer is equal to uniform. Now what it is going to do? From again, it is going to create the 6 units. It is going to create the 6 units. Dense means old 6 units with this one, total 36 connections it is going to connect. And these 36 units are given with respect to kernel initializer is equal to uniform. Uniform initialization. Again, it is going to take with respect to uniform distribution and it is going to initialize the weights. Right? This is also ReLU. This is ReLU. This is ReLU. 36 weights are initialized. 24 weights are initialized. Now, next, I am going to take the next one called as add dense of 1. This time only 1 neuron. So, 1 neuron. 1 neuron with activation function of ReLU, kernel initializer is equal to uniform. I have added only 1 neuron and kernel initializer is equal to uniform, and this is also ReLU. And I have stopped. I have stopped means automatically this is the output neuron. If you have not stopped, you have continued. You have continued again. Then it is also one of the hidden layer. Stop. Wherever you have stopped, the last one is the output layer. Only for the input layer only we have to write the input dimensions. Remaining all of them are units only. Remaining all the layers are units. For example, now this code, whatever the code is there, this code is going to create this neural network. First one is 4 units, input dimensions is equal to 4, units is equal to 6, units is equal to 6, and units is equal to 1. So whatever you are having here, input dimensions 4, units is equal to 6, units is equal to 6, units is equal to 1. Is that clear? When adding the input layer and first hidden layer should be added at a time. You have to add both of them in a single shot. For that, you have to continue with the next layer. Okay. Now, is that clear, guys? For they have not created. For output dimensions, why we are not, for output layer, why we are not using output dimensions means they have not created. If they have created, we used to use. Now, there is no difference between the instruction of the second hidden layer versus output layer. There is no nothing, right? Everything are same. Automatically, only first hidden layer you are hiding the input dimensions. For example, let us take like this. TV, radio, newspaper example with respect to says, that is the data set. TV, radio, newspaper and says. Now, how many number of, earlier I have told you 8 points. What are the 8 points? First one, number of input neurons in the input layer. How many neurons I have to select? 3, fixed. Next, second point. What is the second point you have written? Number of hidden layers. That I don't know. I have told you I don't know number of hidden layers. So what I'm going to do is I'm going to select one hidden layer. I'll select only one hidden layer. First, I'll start with one hidden layer. I'll not start even with 2. First, I'll start with 1 only. Whatever you are saying here, first, basically, I also have written only one hidden layer only. Later, I observed the accuracy I have got only 70% or 72% something. Now I have added one more hidden layer. Right? Now, just I want to add one hidden layer here for this data set. TV, radio, newspaper. Okay. I don't know. Completely I don't know. Right? Here I don't know with respect to how many hidden layers I have to select, and in the first hidden layer or in the second hidden layer, how many neurons I have to select also, I don't know. Blindly I'm selecting minimum number of neurons should be 2 minimum. You can't go minimum less than 2 in the hidden layer. Minimum 2. Maximum infinite. There is no rule. So what I'm going to do is I'm going to select initially 4 neurons, only 4 neurons, and that to one hidden layer. Okay, one hidden layer. Second point, number of hidden layers. I'm selecting only 1. So what is the third point? Number of neurons in the hidden layer. I'm selecting only 4. Why? For these 2 questions, there is no answer. Both are random. Initially, I'm selecting. Okay, next point. What is the next point? Number of output neurons. Now, here in this case, how many number of output neurons? 1. This rule is available, so I'm applying the rule. If the rule is there, I will apply the rule only. If the rule is not there, I'm saying that there is no rule. Right? Next, what is the 5th point? Connections. So weight initializer. So what I'm going to take is this one as uniform. Means between them, between whatever I am having, uniform. That is 12 weights. These 12 weights I'm going to select as uniform. Okay, next. Activation function. I'm going to select ReLU. Hidden layer, I'm going to select as ReLU. By default, first one, I'm not going to do any changes. ReLU. Okay. Next, similarly, this one also I'm going to take with respect to same uniform. This one also I'm going to select with uniform. And 100% I have to go with ReLU only. There is no other option for me because this is a regression problem. Right? Now, next, what is the next one? Optimizer. So I'm going to apply the optimizer called as gradient descent. I'm going to select the gradient descent as the optimizer. Okay. Next, what is the next one? Loss function. Now, what is the loss function I'm going to select is mean square error. Okay. This is everything are fixed. Now, for this, I have to write the code. Now, how I am going to write the code? Miss, first model is equal to sequential. This is the first point I'm going to write. For this model, I'm going to add what I'm going to add, miss, units is equal to 4. For this input dimensions, first input dimensions you have to select. Input dimensions is equal to 3 and units is equal to 4, and in ReLU as the activation function and uniform as the initializer. Now these all the things has to be connected to each other. Connections I have to get means dense. I have to add the dense. If I don't use the word of dense means it will be like this. Without connections, it will be like this. Connections will not be there. So whenever you have written the word, automatically connections will come. Now, once the connections are there, connections are ready. Now, model dot add, and again units is equal to 1 ReLU uniform. And I'm going to take the dense. Completed. And for this, I want to apply the model dot compile. Compile. What is the what is the optimizer? Gradient descent. I want to select the gradient descent, comma, and mean square error. I want to focus on the mean square error. Finally, you have to select the local minima such a way that mean square error is low. You have to focus every time on the mean square error. Whatever the first time one epoch is completed, one iteration is completed, the weight should be updated in such a way that the overall gradient, as per the gradient descent, it has to reduce the values. Right? This is my requirement. Now, once I do this one, now whatever the model is ready, for this model, I'm going to fit the data, that is X train, Y train. Model ready. Now I'm going to fit. Now, once I fit the data, it is going to send the information. And after the sending information, every time it will calculate the Y hat. After that, mean square error. Again, according to that, weights will be adjusted, everything will be done. Now, what I'm going to do, model dot predict on the X train. Only this is the difference. Remaining again same. Model dot predict on X train, model dot predict on X test. After that, calculating the mean square error. After that, calculating R square value, whether it is a overfitting or underfitting. Again same. There is no difference. Data pre-processing same, evaluation is same. In between, model only changes. Okay. So only the CRISP-DM methodology 4-step only changes. Business problem understanding not change. Data understanding not change. Data pre-processing not change. Evaluation not change. Presentation not change. Deployment not change. No changes in all of them. Only changes in the model. Right? I'm going to predict on the X train. And I will predict on the model dot predict on the X test. Now, I will see the accuracies, R square value. R square of train, R square of test. Now here I have got 70% and this is 65%. Assume I have got like this. Now, okay, it is neither overfitted or underfitted as of now. Just exactly 5% only is there. So no, not overfitted or underfitted. But my target is 80. It is not satisfying. Now what I have to do? Option 1 is to increase the number of neurons in the hidden layer. Option number 1. Option number 2, I will keep the number of hidden neurons as it is, but I will add one more hidden layer now. One more hidden layer with 4 neurons one more time. As number of weights increases, what happens? Number of weights increases. In the linear regression, as the quotient values increases, what happens? Accuracy increases, right? In the polynomial regression, you have seen the number of quotients increases. What happens? The overall accuracy increases. After a certain period of time, it will lead to the overfitting problem. Degree of 1, degree of 2, degree of 3. You have applied, right? After degree of 3 only, degree of 4 only have given the overfitting problem. Till degree of 3, it is a normal only, right? So till degree of 3, it is normal. Degree of 4 has given the overfitting problem in the TV, radio, newspaper example. Whatever the example we have done in the class. Where degree 3 has given the good answer, 4 has given the overfitting problem. Similarly, here also, second hidden layer I'm going to add. I will check again the train accuracy, test accuracy. I will add one more hidden layer. I will add one more hidden layer. If certain point of time where it is going to lead my requirement of 80 I'm getting, but with overfitting problem I'm getting, then now I'll focus on the overfitting problem. How to reduce the overfitting. Till that, first I'll focus on the accuracy. I want to improve my accuracy. Once it leads to the overfitting, then I will reduce the overfitting by different options. I will come back then. It is clear now? So first only we are not going to design directly. We don't know anything. Right? So now here, what I'm going to do is, So here first sequential and add, next add and compile. Optimizer is equal to Adam. Adam is gradient descent. Okay. Optimizer is equal to Adam is gradient descent algorithm. And loss function is equal to mean squared error. I want this one as the loss. Loss means automatically you have given the loss means it has to be reduced. You have used the word of loss means automatically the meaning is it has to be less. You have used the metric. Metric means it has to be high. Right? So now whatever the things are there, this I have written very clearly for you with respect to the comments. With the comments I have written that initialization the ANN. Adding the first input layer and first hidden layer at a time. Adding the second hidden layer. Adding the output layer. And finally compiling the ANN with optimizer along with the loss function. This I have written very clearly for you here. But in real life, we are not going to write that much of comments. We don't need to write the comments, right? Comments are what, for what purpose we are writing the comments? For our understanding purpose. In real life, why I have to understand myself? I already know, right? Subject. For my purpose, why I will write the comments. So directly, simply, I will write like this. Once this model was designed, now this model, whatever the model is there, I'm going to store in a variable. Now for this variable, I'm going to fit on the X train, Y train with batch size of 32. Now stochastic gradient comes into picture. Batches means now individual batch. For individual batch, separately. For this batch, identify the minimum value. For this batch, identify the minimum value. For this batch, identify the minimum value. For each batch, identifies the minimum value. And overall, it gives the global minimum value. So here, I'm going to divide the entire data into 32 batches. Whatever the entire data is there. Now here, whatever the entire data is there means, total how much is the data? 9568. Out of which training purpose you are using 80%. Now 9568. Check here. 9568. 9568 into 0.8. Where you have got 7,653 records. 7,653 records divided by 32 batches. Each batch will consist of 240 records. So here each batch will have with respect to 240 records. See 240 by 240, 240 by 240. The word of 240 means each batch is having 240 for 240 records. Okay. The entire data was divided into 32 batches. For example, here I'm having with a total of 150 students are there. 150 students I want to divide into 10 batches means what I will do? In each batch 15 students. Same thing. First in this 15 students, I'm going to identify who is the topper. Next 15 students, I'll identify who is the topper. Next 15 students, total assume 150 students are there. Within these 15 students, one topper. Within the 15 students, one topper. Like this, I'm going to identify how many toppers I am going to get. 10 toppers I am going to get. Out of these 10 toppers, now I am going to identify overall topper. Right? So, batches wise, we are going to divide the batches wise so that the work will be easy. Why we are dividing the batches means the work will be easy and correctly will identify. When compared to overall, here the identification is easy. Okay. So now, so train batch of 32, epochs of 100. 100 epochs means 100 times it is going to do the iterations. It will first calculate the MSC, first iteration. See, first epoch of 1 by 100. First iteration, the loss, it has got this much, the mean square error. After that, it has adjusted the weights. Again, it has calculated the loss function. That is again mean square error. Again, it adjusted the weights. Again, it calculated the loss function. Again, adjusted the weight. Again, calculated the loss function. Like this, it has calculated the loss functions. Overall, the loss function was decreased. So why you have selected epochs only 100? Initial value. It is not mandatory that I have to select this one only. For batch size also, there is no rule. Everything are hyperparameters only. There is no rule for none of them. For none of them is no rule. The less number of rules, the more number of trial and error, the more the complex subject in the market. Everyone will assume. Because there is no fixed rule. Since there is no fixed rule, that is the reason artificial intelligence is the difficult subject. If the rule is there, everything, batch is fixed, epoch is fixed, everything is fixed, means what is the difficulty here? Tell me what is the difficulty? Writing the code is difficult, yeah. Copy paste only, na? Why machine learning is easy? Why artificial intelligence is difficult? Because more number of parameters, unknown data. We have to try in a different options. More number of unknown data. Clarity less, unclarity is more. That is the reason in market, everyone will feel that artificial intelligence is a difficult topic. But actually, artificial intelligence is not a difficult topic. Coding part also easy. Just you have to apply the logic of for loop or grid set CV. Whichever you don't know, try with different values. Keep in the grid set CV. Parameter grid is there, right? Param grid is there, right? Apply the param grid. Inside the param grid, you keep the epochs. Epochs is equal to 16, 32, 100 batch. Multiple batches. How many batches you want? That many. Right? Whatever the number you are interested. It will apply all of them. Sir, I want to try from 1 to 100. Take the range. List of range of epochs. Epochs of instead of range of 10 to 1000 with an increment of 10. First, it will try epochs of 10, 20 epochs, 30 epochs, 40 epochs, 50 epochs. Like this, it will try all the different models. The only thing is, the system will take so much of time because you are asking that many things now. If you ask only epochs of 100 one time miss, it will execute just in 2 minutes. If you are asking these many epochs to try miss, one more it has to try miss, it will take time according to that. More time it will take. More processing is required, and that's it. Nothing else. Right? So here, once we execute the code, that is compiler. Compiler is clear, right? That is optimizer, and loss function is called as compiler. Which one you want to compile? How you want to compile? In what way you want to decrease, and in what algorithm you want to apply? Which algorithm you want to apply and decrease? Gradient descent algorithm you have to apply and decrease the error. Right? Now just fit the data on X train, Y train, batch size, and epochs of 100. Now once you are predicting on X train, predict on X test, and calculate the mean square error, calculate the R square values. Simple. After that, evaluation is common. Now comes to the same thing in the classification example. Same to same classification. Now, sir, how to do the cross validation? How to do the hyperparameter? That I will explain. First, let us complete the modeling. How to do the modeling? Let us understand modeling part very clearly. Later, we'll focus on the cross validation and that hyperparameter tuning within the ANN. That will focus. Is the modeling of this one is clear? You have to understand only this part. This part is clear, miss? Done. Out of this part, obviously it will be clear because this one is fixed, only this one is fixed. Remaining are unknown only. None of them is fixed. Blindly we have taken. Why? In the textbooks, or if you go with the YouTube videos, they'll simply say that because we are not asking any questions now. That is a recorded video. So they'll simply say, they will type simply activation function is equal to ReLU, kernel is equal to uniform. They'll type and they'll continue. Simply they'll continue. Why? They'll not tell anything. We assume that, oh, this is the only option. If I don't say that these are multiple options are there, you don't know, right? Since I told you that multiple options are there in the kernel initializer, multiple options are there in the activation functions, now you are getting the doubt which one you have to apply. If I don't say anything, if I say only ReLU function and sigmoid function, only these two options are there. And in hidden layer, you have to always go with the ReLU and the output activation function. This one is fixed like this. If I say miss, artificial intelligence is very easy. If I said nothing is fixed miss, artificial intelligence is the difficult. Right? None? Is that clear, guys? Any questions? Now, this is the model. Now, once you have to create the model, and after creating the model, you have to save in a variable model name, whatever the model name you have to create. And inside that, you have to fit on the extend byte. Now, the same thing. Let us see in the classification. Import NumPy, Pandas, TensorFlow, and Keras. Here, I'm going to work on the data set called as churn modeling. Churn modeling means whether the person is going to churn or not. What is meant by churn means whether the person is going to leave the company or not. Churn means whether the person will leave or not. Yes or no. He will leave that one or not leave that one. That is called as churn modeling. Right? Now, this is a classification algorithm, which is a binary classification algorithm where I'm having the output whether the person will churn or not. Yes or no. Okay. So whether the person will exit the company or not. Now here I'm having multiple parameters where the output variable is binary classification problem. Now if I apply here total number of columns are 14 columns. The data sets are 10,000 records. 10,000 comma 14. Now what I'm going to do out of these 14, first one is you have to do the data pre-processing. In the data pre-processing, what are the things you have to do? EDA. After that, data cleaning. What is meant by data cleaning? Removing the missing values, treating the outliers, or with respect to any features which are unimportant features, dropping the unimportant features. Row number is unique for every record. It is going to be unique. 1 to 10,000 will be there. There will be no difference, right? 1 to 10,000. Every value will be the unique. Customer ID from the top to bottom, everything will be unique. Surname, everything will be unique. There will be nothing will be there. So these three are not depending the output whether the person will leave or not. So row number is going to decide that whether the person will drop the company or not, right? Whether the customer ID will depends upon whether the company, whether he is going to leave or not. Whether his name is going to decide. No. So these parameters are not going to decide. So I'm going to drop the unimportant variables which are not important. Right? Unimportant variables I'm going to drop. Now, after dropping, now how many variables I'm having? 11. 10,000 comma 11. Out of these 10,000 comma 11, 10 of them are input variables. One is output variable. Now, these 10 input variables, I'm going to observe how many of them are with respect to categorical. How many of them are categorical? And I'm going to apply the encoding according to that. So one of them is geography. Okay. Geography, where I'm having with respect to 3 unique categories are there. France, Germany, and Spain. Now, these are the just names of the countries, whether it is a nominal data or ordinal data. Nominal data. Nominal data means dummies, one hot encoding. Next, gender. In the gender also I am having male and female. Just it is a one hot encoding. Again, dummies. For this one also we are going to apply dummies. Dummies or label encoding. There will be no difference. Now, 11 input columns. Out of 11 input columns, 8 of them are continuous. 2 of them are discrete. 8 of them are continuous. Okay, 2 of them are discrete out of 10 input columns. For these 8, you are not going to do anything because data cleaning was done. There is no missing value. Nothing missing value is there. Encoding. These 2 variables you are going to do the encoding. Out of which you are going to do the geography with respect to one hot encoding. For gender also one hot encoding you are going to do. That is nothing but get dummies. Now after getting dummies, now if you see overall we are having with respect to 8 along with the 3. Because why 3? Within these 2 discrete variables, one discrete variable consists of 3 categories. 3 categories means how many columns it is going to create? 2 columns it is going to create. Already 8 columns are there. Now it is going to create 2 columns. Now one more discrete variable where it is having the 2 categories, that is gender category, 2 categories are there. How many columns it is going to create? 1. So total how many you are going to get from 2 discrete columns? 3 columns it is going to get. So that is geography with Germany, geography with Spain, whereas France was dropped. Drop first is equal to France was dropped. Similarly, gender female and male, out of female was dropped. So total how many input columns you are having? 8 plus 2 plus 1. Total 11 input columns. After applying encoding, 11 input columns you have got. Why I am explaining like this? Because number of input columns only, the number of input dimensions will be decided. Now, based on input columns, we are going to decide the number of input dimensions. That is, input layer number of neurons will be decided. Now, 11 input variables and 1 is output variable, which is a Output variable is a discrete variable where you are having binary classification. Two classes are there in the output variable. Sir, you are explaining somewhat very fastly, sir, this part. Is there any new thing I am explaining in this? For the previous data, any data till now, whatever we have considered, same EDA we have taken, same data cleaning. If the discrete variables are there, encoding. Same thing only, right? In the decision tree, we have done the same. Random forest, we have done the same. In the XGBoost, we have done the same. In the data pre-processing, nothing changed. Forget about deep learning concept only. There is no artificial intelligence. Forget. Assume this is only machine learning code. In the machine learning, what you have to do in the data pre-processing, do the same thing. No special things. Assume this is only a normal machine learning code. Then in the data pre-processing, what are the things you are going to do? Same thing you have to do here. Nothing special, right? Next, sklearn, where train test split. You are going to split the data. That is 20% you are going to select as a test data, 80% you are using the train data. Out of 10,000 records, 8,000 records are used for training, 2,000 records are used for testing. I am applying the scaling because in order to bring everything on the same scale. Because in my data set, I have observed one of the data column is having very big numbers. Salary is the very big number is there. 93,000 here, whereas remaining all the values are CIBIL score is with respect to 6-1 and age is only 2 digits. But this one is having with a very big numbers. So this one and balance, these both are having very large numbers. So I want to bring everything on the same scale. For that, I'm going to apply the scaling. In the data pre-processing, none of them I have touched. As it is, I'm going to use. Once, now how many input columns you are having? In the X-train, what is the shape? 11. 11 input columns are there. Now you are going to use the keras.model import sequential, keras.layer import the dense. Same to same, whatever we have done in the this. ANN is equal to sequential. You are going to store. Here I have stored that same thing in the model. I have written the model name. Here I have written the ANN, some name. ANN dot add. Same thing. Whatever add, input dimensions is equal to same 8 steps. Read once again the 8 steps, whatever you have written. What is the first step? Input dimensions. How many input number of neurons should be selected? 11. So I'm writing input dimensions is equal to 11. Second, what is the second step? Number of hidden layers. I'm going to select 2 hidden layers. That is my requirement. I'm going to start with 2 hidden layers. Next, in each hidden layer, I want to give 6 values. So I have selected units is equal to 6. Okay. Sir, why you selected 6 only, sir? There also you selected 6 only. Here also you are selecting 6. Is the 6 is fixed every time? Not interested, huh? 16. Change. There is no that is the reason I have changed immediately 16. Minimum 2. Minimum is 2 in the, we have to select in the hidden layer. Maximum, generally till now what I have observed is whatever the number of input features you have selected here, 11, if 11 are there means plus 10, means maximum 21 neurons only we are going to select. We are not going to cross more than 21, generally. Minimum 2 to maximum 21. For example, earlier example, whatever the earlier example is there, here I am having the input neurons 4, right? So hidden layer neurons, maximum 14. Don't cross more than 14. If you want to increase number of layers, you increase. But don't increase the number of neurons in the hidden layer. Right? Now, when you are increasing the number of, for example, if you increase the number of hidden layers, the weights increases. If you increase the number of neurons in the single hidden layer, so weights increases. But rather than this one, this will work very fast. Right? Actually, that is also not rule. That is also not rule. Whatever I have told you, that is with respect to 11 plus 10. Don't cross more than this one also. It is not a rule. There is no rule like that. Rule is not available. But generally, we'll take like that. Okay. So I'm starting with initializer. Kernel initializer is equal to uniform. Activation is equal to ReLU. Next, 6. Kernel and uniform, ReLU. Next, dense is equal to 1, uniform, and output variable sigmoid. Now what I have done is first one, 11 neurons. I have selected 11, followed by 6 neurons, followed by 6, followed by 6, and followed by 1. 11 neurons. If I draw means 11 into 6. If I draw also, there will be no use. Completely, it will be in a zigzag way. Okay. If I draw 11 neurons and if I connect them also, the lines, 66 lines, if I draw also, there will be no use. You can't see that one. Right? Whatever the rough lines I have drawn, you will feel like that. So here total 11 into 6, 66 weights. 6 into 6, 36 weights. 6 into 1, 6 weights. Total, it is going to create with respect to 108 weights, it is going to create. 108 weights, it is created the neuron. 108 neurons are connected to each other. In the body, 86 billion neurons are connected. Here, just we are connecting only 108 neurons. Okay. So, if you connect more number of neurons, automatically you'll get more number of accuracy. The more number of neurons, more accuracy. At the same time, overfitting also. Okay. You have to do properly. Right? Now, here, the neurons, that is 11, 6, 6, and 1. This is fixed. This is fixed. Here, ReLU, I have selected activation function. ReLU acts the activation function. Output, binary classification problem. So, sigmoid is the activation function. For hidden layers, I am going with the ReLU. For hidden layers, I am going to select the kernel initializer is equal to uniform and activation functions is equal to ReLU. Right? Now, automatically the last one is, whatever the last one is there, that is the output layer by default. Now in this, if you, here I have written in the separate cells. I have written in the separate cells because we are in the learner stage. I have written in the separate. But once we are experienced, we are writing everything in the single cell only. No need to write in the separate cells. This is the only single cell is sufficient for you. The same thing. Whatever above is there, the same thing. In the single cell only, write everything. Compiler. Now compiler, once again, it is going to be Adam. And matrix is equal to accuracy. Loss function is binary cross entropy. It is not mean square error. Mean square error is for that one. Binary cross entropy. What is meant by binary cross entropy? So already we have discussed the entropy. Do you remember? In the decision trees, we have discussed entropy. Entropy means, which is nothing but minus P log to base to P sigma of minus sigma P into log P to base 2. Do you remember? So whatever the this we have discussed in the that one, the two classes, whatever the two classes are there, the two classes we are going to calculate the entropy between them. Okay, that entropy is considered as binary cross entropy. Binary cross entropy, to be more simplified for you, misclassification rate. In a simplification, it is called as misclassification rate. I want my misclassification rate should be low. Miss, nothing but TP, FP and FN. These both should be low. Binary cross entropy miss opposite. FP, FN. Okay. Binary miss opposite to each other, which are opposite to each other. Okay. Two classes, binary cross entropy. We are going to select the binary cross entropy. And here I have given the epochs is equal to 100 with batch size of 32. Total how many records? 10,000 records. Out of which for training purpose, how many records? 8,000. Testing? 2,000. Out of these 8,000 records, now I am going to take batch of 32. Now each batch, how many records will be there? 8,000 divided by 32. So in each batch, 250 records will be there. In one batch, 250 records will be there. So each batch, it is going to calculate the loss function along with the accuracy value. It is going to calculate for each of them accuracies. For 100 epochs, it is going to calculate the accuracy. Once it is calculated the accuracy, I'm going to predict on the X test and I'm going to see the test accuracy, which is 0.8675. and this is the confusion matrix. Evaluation is common. Once again, you are going to select the confusion matrix, accuracy, everything is common. Is that clear, guys? Modeling and evaluation. If you want to predict on X-train, means train accuracy. Predict on X-train and you will get the train accuracy. Because the sigmoid is the activation function. What is the output? Final output is here in the final output neuron. Sigmoid is the activation function. Then what you are going to get as the output? Output of sigmoid is what? T value, probability value. What is the sigmoid range? 0 to 1. 0 to 1 means 0 to 1 it is having the range. The output will be 0, 0.1, 0.2, 0.3, anything. From 0 to 1, it will give anything. Now, how I can take that? I want the classes. The output I have got as 0.1 or 0.2. Now, how I can convert this one to classes? Wherever the value is greater than 0.5, it is considered as class 1. Wherever the value is less than or equal to 0.5, it is considered as class 0. The same thing I have written here. Wherever the vibrate is greater than or equal to 0.5, it is considered as class 1. Automatically remaining part is 0. Is that clear? So you can write here the same ANN dot predict on X train. You can create ANN dot predict on X train and you can calculate for that one also 0.5. If the value is greater than 0.5, convert to 1 and calculate the accuracy of train accuracy also. Calculate the train accuracy, calculate the test accuracy. Here, I'm not going to write that code. If I write the code and if I execute means, again, it will throw the error for me, name error, because above lines I have not executed. None of the line I have executed. Why I have not executed? Just I'm explaining because it will take time for execution. 20 minutes it will take for time for execution only. So I have to wait for 20 minutes. Once I click on this one, this particular cell will take 20 minutes of time. Right? Now, so here, now if you want to do the cross validation. So generally we know evaluation. In the evaluation, what are the things we have to check? 1, whether the train accuracy is equal to or test accuracy, that is overfitted or underfitted. 2, your test accuracy should be equal to CV, cross validation score. So in order to check the cross validation score, what we have to use means from sklearn.wrappers, we have to import the Keras classifier. For classifier, we have to import the Keras classifier. For regressor, we have to import Keras regressor. Okay. And we have to give this as the input. Now this we are going to select here the cross validation score and we are going to see the whatever the cross validation value. Okay. If you want, I'll execute from the starting. Let us take it, though it takes time also, let us execute what happens. TensorFlow itself, it will take 2 or 3 minutes of time when compared to other libraries import. Pandas will be imported just in 1 second or 2 seconds. Means TensorFlow will take at least 50 seconds to 1 minute. Depends upon the system. Sometimes it will take 2 minutes also. Okay. TensorFlow import also, it will take time, basically. Now, first, what I'm going to do first directly, I'm going to do the modeling. So once I have done the modeling, basic modeling, now if it is overfitting, I told you, first you have to focus on the number of layers. How many layers we have to fix, that we have to focus. And we have to increase the layers till we get our requirement accuracy. Our required accuracy is 90%. Till that, we have to increase the layers. So one by one layer. Once we observe the overfitting problem, after increasing the number of layers, we have observed the overfitting problem. Now we have to reduce the overfitting. How to reduce the overfitting? How to reduce the overfitting in AN? We are having 3 different options for that. Option number 1, in order to reduce the overfitting. One is hyperparameter tuning. Again, come back and adjust your neurons and according to that. Second option, regression. That is lasso or ridge regression. Third one is dropout. Majorly we'll go with this one. Dropout. Dropout means it is going to drop some of the connections. So here, initially I have taken the 11, 6, 6 and 1. 11 into 6 means 66, 36, 6. Total 108 connections I have created my neural network. Assume that this particular neural network has given me the overfitting problem. Assume. Now in that case, what I'm going to do means I'm going to select the dropout. Dropout is equal to 0.1. Dropout of 0.1 means 10% of the weights will be dropped. Out of 66, 6.6 weights. 6.6 means 7 weights will be dropped randomly. Randomly 7 connections will be dropped. 7 connections it is not going to take. 59 connections only it is going to do. Sir, why sir? Very simple. Don't ask any that why sir, why we have to drop the weights. Simple logic, very simple logic. Y hat is equal to beta naught plus beta 1 plus beta 2, beta 3. If you take more number of betas, what happens? More number of quotients, beta, 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 beta. If you take up to beta 99, what happens? If you go with the degree 99, what happens? The same thing, right? The higher the number of y in the polynomial regression, as the degree increases, why we are observing the overfitting problem? Reason behind that is why? Why? Question is why? Simple. Reason is very simple. The more number of quotient values increases. Quotients, more number of quotients increases. As more number of quotients increases, more precisely it is going to calculate. For what? Trained data it is going to calculate more precisely. When the trained data more precisely it is calculating, test data it is failing. On the train accuracy is getting more perfect because precisely it is going to do, right? So test data, train data is perfectly working, test data is missing. So as the more number of quotients increases, the overfitting problem will be there. Here the coefficients in the machine learning is called as weights in the deep learning. Both are same, I told you, right? The equation is in the beta naught plus sigma of I is equal to 1 to n beta n xn. Here the equation is b plus wi xi. Both are same. Sigma I is equal to 1 to n wi xi. Right? So whatever the formula we are having, beta I xi plus b, here weight plus b, also same. Both are same. As number of quotient increases, it leads to a overfitting problem in polynomial regression. Here also, as the number of weights increases, it leads to the overfitting problem. As more in the ADA boost or in the gradient boost or in the exit boost, if you go with more number of decision trees, what happens? Instead of going with 100 decision trees, if you go with the 300 or 400 decision trees, what happens? The same topic in the Google, you have downloaded the interview questions for the first time and you have prepared the interview questions. Same questions you have repeated 300 times, you have repeated. Today one time, tomorrow one time, day after tomorrow one time. Like this 300 days continuously you have repeated the same question. What happens? Even in the midnight if you ask also, you will tell. Just if I wake up you also, you will tell immediately. That too, as is the sentence also, even the letter also will not change. 300 times you have told me the same answer multiple times means what happens overall? Overfitting on. Right? Similarly here also, as the more number of weights increases, it leads to the overfitting. So in order to reduce the overfitting, we are dropping some of the weights. Is one of the option. Is one of the option. Similarly, we are having lasso regression, ridge regression. This is one of the option which we have seen in the regression. This is one of the option which we have seen in the machine learning. All the options, these two options anyways you know earlier itself. This is the new option. Dropout. Dropout is going to be used when you are having the overfitting. If there is no overfitting, don't use the dropout. So how to use the dropout means, here I have written the code for dropout. Dropout rate is equal to 0.1. So now what total 11 into 6, 66 weights will be selected, out of which 10% will be dropped. 10% means 6.6 weights. 66 weights minus 6.6 weights. 6.6 means since the value is greater than 0.5, it is going to take round figure of 6.6, which is 7. So minus 7 weights it is going to drop and 59 weights will be considered. Right? If I remove this line, if you remove this comment and if you write miss, 59 weights will be there. Instead of going with the 66 weights, 59 weights will be there. Which 6 weights are removed? Which connections are removed means randomly. Randomly it is going to drop. Okay. Randomly it is going to drop. Similarly, this is also drop. Okay. Drop out means in terms of drop the neurons, drop the connections. Why you are dropping means in order to reduce the overfitting. If there is no overfitting, no need to drop. In order to reduce the overfitting, one of the option is dropout in deep learning. In ANS, one of the option is dropout. Is that clear? Percentage. Generally, we'll go with 10%. Okay. If you drop more number of things, then there is no use of connecting. So just in order to reduce, we are dropping 10%. So now we are going to take the values and we are going to predict the test accuracy. Similarly, you predict the train accuracy. Y-pred test. Y-pred train. Y underscore pred underscore train is equal to ANN dot predict on X train. You are going to take X train. Y-pred underscore train on the X train. You are going to take on X train. Similarly, this one also. Y-pred test. Whatever the Y-pred test is there, Y-pred test is equal to Y-pred test greater than or equal to 0.5. And Y-pred train is equal to Y-pred train greater than or equal to 0. Whichever the greater than 0, that part we are going to consider. Remaining part is automatically 0. Right? So now you are taking this one and now you are going to predict, that is accuracy score. Import the accuracy, train accuracy, test accuracy. So print train accuracy, print train accuracy, train accuracy, colon, comma, accuracy score between Y-pred test that is Y train versus Y-pred train. So you are going to get train accuracy, test accuracy, right? And if you want to see the confusion matrix, you can see the confusion matrix. Otherwise, no need. Okay, choice is yours. Now I want to do the cross validation. In order to do the cross validation, so I have to select this one. Everything, whatever I have created, that I have to store in a function. And I have to select the Keras classifier. Once I select the Keras classifier, now I'm going to apply this one. Here the cross validation. So value error where transform take one positional argument but two were given. Transform. Where is the transform? Classifier and X comma Y. Sir, pure nodes will get an overfitting problem arise. Then only we are going to select the maximum percentage of dropout is 10%. Okay, generally we'll drop the 10%. Maximum is 10%. Done. Less than 0.5 will be considered as 0. Automatically whatever the values less than 0.5 are there, it is considered as 0. And greater than 0.5 are there, which is considered as 1. If you don't write this thing, without writing this thing, just you execute only this one and see what is the Y-pred test, what is the values. You will observe with the probability values. That probabilities you are going to convert wherever the value is greater than 0.5, you are converting as class 1. Is that clear? Now, you are going to apply the cross validation score. That is cross validation where we have to give the complete classifier. Classifier is nothing but this cross classifier, where this cross classifier, I'm going to take cross belt classifier, batch size is equal to 32, epoch is equal to 100. This is correct. Classifier X, comma, Y, comma, CV is equal to 5. 11, 6, 6, 1. Value 5, fits failed. Where it is transforming. Scoring is equal to accuracy. What it is failed? X has small. X data is same data, right? Complete X, whatever the complete X is there. Okay, transform data, whatever the transform, fit and transform we have to do, right? So let us select this X train. No, X train will not be selected because X1 already transformed. X is already transformed and converted. Encoding also done. Let's give it a try. No, it is not working. Auto arguments. Line 142. Pipeline wrappers. Okay, let me check this one and I will send you the right code. Okay. Now, once the class validation score is also completed, you are going to see the cross validation with respect to whatever the value. And you have to compare the same way. Train accuracy, test accuracy, how you have compared, whether it is a overfitted or underfitted. Similarly, the test accuracy you have to compare with your CV. Right? Once this is done, now how to improve the betterization? How to do the betterization means by applying the tuning. So hyperparameter tuning or regression or dropout. So how we are going to do means, see here, estimator is equal to Keras classifier, build cross classifier. Okay, this one I think. It will work now. Devda. What is this? Cross classifier, again error. Again transform, same. Okay. So let me check. I'll check once again. So Keras classifier, build cross classifier, and param grid, I'm going to take the batch size. Since I don't know the batch sizes, I'm going to select epochs also I don't know. And optimizers, different types of optimizers with respect to Adam and RMS prop. Like this, we are having different types of optimizers. You can select the optimizers. And if you are interested in the neurons, instead of optimizers, if you are interested in neurons, like for example, activation functions, neurons, and layers. So as one of the student will ask me, sir, I want to select the layers, only one layer. Layer is only one hidden layer only. First time I want to go with 10 neurons, after 20 neurons, after 30 neurons, and after 40 neurons. Then what is the code I have to write? Then you have to write the code here with respect to the layers. You have to select the layers. Okay, you have to take the layers. With layers is equal to this one. Option is equal to 20, 10, 30, 40. So whatever the options we are having, it is going to take one hidden layer with different options of number of neurons in that layer. Hidden layer is one hidden layer only, but different options of neurons. If you want multiple hidden layers with different options, means this is the kind, right? So if you want with respect to the batch size or all these things, you are going to just apply the grid set CV, right? So generally what we'll do is, most of the times, if you want to change the number of neurons in the hidden layer, or if you want to increase the layer, means just here only we are going to change. Rather than going with respect to that grid search CV will take so much of time. If you try in the grid search CV, it will take literally so much of time. There is a high probability that your system will crash, or with respect to any kind of errors you'll get. So that is the reason. Generally, we'll go with here. 90% of the cases we'll try here only. Okay. And whichever the values you want to apply different values, that you are going to take in the param grid and grid set CV, and you are going to identify the best parameters. And using that best parameters, again, you are going to rebuild the model. Remaining everything is as it is. Only the change in the model only. Only one and only changes in the model. Okay. So what is the difference between the machine learning versus any machine learning algorithm versus ANN? First step of business problem understanding, same, no change. As it is, both are same, equal to. Second step, data understanding, same, no change. Third step, data pre-processing, no change. Here also the same data pre-processing. Assume whatever the data they have given, we have to do the EDA here. Data cleaning, that is missing values, and encoding, data wrangling, train test split, and after that you are going to do the scaling. After train test split, you are going to apply the scaling. Same thing you have to do here also. Same data, right? If you are, for example, the churn modeling data set is there. Let us take the same churn modeling data set. This churn modeling data set, if you are applying the ADA boost, that is classification algorithm, right? ADA boost. You want to apply the ADA boost or gradient boost or decision tree. Then what is the steps you are going to follow? Same steps, right? You are going to do the same EDA. You are going to treat if there is a missing values. You are going to treat the encoding, and you are going to apply the train test split. You are going to do the scaling. Same to same. Whether it is a machine learning, whether it is a deep learning, till this there will be no difference. The only difference in the step 4 called as modeling. Here we are going to import. Here we are going to create. Here we are going to import directly. Whatever the model is there that we are going to import, here we have to create the ANN. That is the only difference. The model we have to create. Model itself we have to create as per our requirements. Here, evaluation, we are going to do the evaluation, that is train accuracy, test accuracy. Here also the same evaluation. These both are only not equal. Modeling only is not equal. Evaluation also same. Same test accuracy, train accuracy. After that, sixth step, model selection. You are selecting whether that is a good model or not. That is with respect to in this and in this. Train accuracy is equal to test accuracy. Overfitted or underfitted. Same to same. No difference. Cross validation score. You are going to do. Same to same. Grid set CV. Same to same. Rebuild once again the models with the best hyperparameters. Again, same to same. Nothing difference. Instead of importing and fit on X train, Y train, we have created the ANN. Instead of directly import, we have created. That is the only one difference we are having between these both. Remaining is same. Okay.